So if you're a .NET developer, you have probably been here before. You've hit a performance wall, and you're not sure why. Today, we're going to dig into a really critical choice you have to make: local versus distributed caching. Let's break it down. It's the classic story, right? Your .NET application is absolutely flying in development. It's snappy, it's responsive, but then you deploy it. Real users start piling in, and suddenly everything just grinds to a halt. So what is going on here? Your first instinct might be to think, what did I break in the code? But this usually isn't a bug. It's actually a much more fundamental scaling problem. And honestly, it catches a lot of developers by surprise. Well, a lot of the time, the culprit is the default out-of-the-box solution that comes with .NET, iMemory cache. Now, what this does is it stores frequently used data directly inside your server's own memory. It's living right there side by side with your application code. And on the surface, that sounds amazing, right? Incredibly efficient. But that efficiency is also the source of its biggest limitation. Let's explore why this local approach has a very hard ceiling when it comes to growth. I love this analogy because it just makes so much sense. Think of iMemory cache as a private little notebook sitting on a single desk. It's super fast for one person to jot things down and look them up. But what happens when your workload increases and you add more desks, or in our case, more servers to handle more users? Well, that notebook doesn't magically copy itself. Each new server gets its own blank notebook. And now you've got a huge problem, because users hitting different servers are going to see completely different data. So yeah, that whole isolated notebook thing, that's just not going to work for a growing app. We need a totally different way of thinking about this, a solution that's actually designed to get past the single server bottleneck. And that solution is what we call a distributed cache. Redis is probably the most common example you'll hear about. So instead of every server having its own private notebook, a distributed cache is more like a central library or a giant shared whiteboard. All the data is stored in one shared location, and every single one of your servers can read from and write to that same single source of truth. So let's put these two side by side, because it really clears things up. With a local cache like iMemory cache, your data is totally isolated inside each server. And look, that's perfectly fine for a simple single-server application. But then you look at a distributed cache. Everything is in one central, shared spot. This means the data scope is shared across all servers, which is absolutely essential for any kind of multi-server app where you need consistency. Okay, so all of this leads us to the big question, the one you have to answer for your own project. Which of these caching strategies is actually the right fit for your system? And look, this isn't about one being good and the other bad. It's not that simple. It's really about understanding a fundamental trade-off. Are you trying to optimize for raw speed, or are you building for scale? And here is the absolute key takeaway from all of this. It's something worth remembering. The thing that makes your application feel super fast in a simple environment is not the same thing that will allow it to be scalable in a complex one. Fast does not equal scalable. So let's just sum it all up. iMemory cache? Yeah, it's blazing fast. You can't argue with that. The data is right there in memory, no network trip required. But a distributed cache, that's what's truly scalable. It's what lets you add more and more servers that all stay perfectly in sync. So in the end, the right choice really just depends on your system size right now, and maybe more importantly, its future architectural needs. And that's really what this all boils down to. So we'll leave you with this final thought to apply to your own work. Don't just ask yourself, is my application fast today? The real question you need to be asking is my architecture truly ready to scale for tomorrow?